Okay, now we'll go back and look at the metal ions. And of course, if you notice, the copper is not visible, the nickel is not visible, the iron is slightly visible, and the unknowns are not. Okay? So, I know since they all went to the top, I can measure my solvent front. And let's see, the color originally, this was blue, this was green, and this was yellow. Okay, so this is nothing, and yellow. Okay, solvent front is going to be the same, so I'm just going to measure it in one place, and it's going to be 5.7, so 57. So it'll be the same for all of them. Okay. Now there's no center color, no center color. So now I'm going to have to develop these. Okay, to do the metals, if you look at the chromatogram, notice the copper's not visible, the nickel's not visible, the iron is visible, and the unknowns, well, this one has a little visibility. So they're not visible, so I have to use a chemical means to make them visible. So I will do the nickel first, and to do that, I take a evaporating dish, put some concentrated ammonium hydroxide in it. I don't need a lot. And then I place my chromatogram over it, and the ammonia vapors will rise up into the chromatogram and react with anything if that's working. Okay, and if you sort of notice, my copper is sort of starting to develop a color. And what's happening is the vapors of the ammonium chloride, which is ammonia, are rising up into the paper. Now remember, this had HCl in there, so it's also reacting with the HCl in the paper. So if you see a white smoke, that is ammonium chloride. Okay, so notice that one's developing. Now I have to develop my whole chromatogram, so I'm going to sort of have to move it along slowly across there. Notice the ammonia is causing the iron to definitely peak. Notice the nickel's not doing anything. Make sure I do my unknowns. And if you notice, you see the development very slowly. Now you know this was copper, so my guess these two might be copper because they're doing the same thing. So maybe both unknowns had copper in them. I don't know yet. We'll know shortly. So I'm going to let them develop a little longer. Go back just to make sure I didn't miss any. So that's my ammonium development for my copper. So that definitely proves copper here. So these two are probably copper too, if you make that quick induction. Now I'm going to develop my nickel. And to do that, I am going to use dimethylgloxamine in a spray can. Now it's mixed in alcohol in here. This is a bottle of air. When I spray that, it'll spray out as a mist. And so I'm going to spray that. And then I'll let it develop. if you notice, as it develops, the nickel is starting to develop a sort of a strawberry color. Unknown C is developing a strawberry color, and my finger must have had some nickel on it because it's developing over here also. But this is still not dry yet, so I can't measure from the center to the baseline yet and develop and make the calculations of my RF value. But if you notice, very quickly you should say, well, this unknown must have probably these two. This unknown probably has this and possibly iron. So my baseline was, what did I say, 57? Yeah, 57 was that. So I'm going to find approximate center, and that's about 4.5. Or 45 million. My nickel, about the center there, is about 5. Okay, then iron, I guess I'll zoom the whole thing, go about the middle, and it's approximately about 40. So I'm going to do my unknown C. I'll do the bottom one first. Find approximate center of that, and it's about 18. Then the middle of that one is about 47. This one about there is about center is approximately about 40. And my iron is way up there, but I'm going to assume about here. So about 53. Okay, so now I'll take my center measurement, divide it by my solvent front, my center measurement here, and then I'll divide it by the solvent front. So you can see it's going to be a large number. Okay. So when I divided this out, I got approximately 0.79, 0.09, and 0.79. So those are my RF values for these. Remember, an RF value has to be under 1. So if I do my nickel, my letter C, I should say, and this was 57, and this was measured about 18. So 18. Okay, so I've calculated all my RF values. I'll have 2 RF values here, and I'll have 2 RF values. Each of these will have 1 value. These will have 2 values. So I pick this, and this is a spot. Pick this, and that is a spot. So we'll have 2 RF values. Now, I will forewarn you that RF values will not always be close to each other. They do have a lot of variance because of difference in paper, and difference in migration, difference in temperature of the room. All of those affect the rate at which something migrates through the chromatogram, and so you will get various RF values. But if you look at it visually, you can definitely pick out this is this and this is that without any possibility of making a mistake. This would probably be that. So these two are probably that. Iron, just because you're getting this, it's probably got iron in it, would be my guess. So that's your metal one, and the data I'll show you here in a second. Let me just move that over so you may see all the data, so you can just see the data. This is the data sheet all complete. What I did is To calculate the RF value, I took the center divided by the solvent front, center divided by solvent front, center divided by solvent front, and got these. Notice every RF value is less than 1. If I got 1 over 1, I have done something totally wrong. So that's how you would use a chromatogram. And some people think it's useful, some people don't. So it's entirely up to the individual doing it.